Hi, we are Team 1 and we are going to present the following topics. Historical development of chemistry as a science. According to historical anthropology, the first controlled use of fire by the first humans on Earth occurred just over 1.4 million years ago. But it was not until 7000 BC when Neolithic humans acquired and perfected reliable techniques to make fire through utensils that produce friction. This was the most significant chemical phenomenon of which humanity has memory. After these first discoveries that impact humanity, alchemy emerged, an ancient technique whose main objectives were to discover a substance that would transmute ordinary metals into gold and silver and find the means to discover the elixir of immortality. Therefore, alchemists are considered to be the first chemists. Alchemy has roots in Egypt and China. It is known that it was practiced from the 4th century BC until the emergence of chemistry and the natural sciences towards the 18th century. During the Han Dynasty, alchemy focused primarily on pursuing immortality and the elixir of life, although alchemy in China failed to find the formula for immortality. Ancient China is known for its great inventions and discoveries. One of his greatest achievements was the invention of gunpowder, a mixture of sulfur, coal, and potassium nitrate that revolutionized warfare and hunting. Chinese alchemists believed fireworks could ward off evil spirits and attract good luck and prosperity. Another reason was that gunpowder was a way to express art and beauty. A third reason was that gunpowder was a military tool. The Chinese used the artifacts to defend themselves against their enemies, especially the Mongols, who invaded China several times. As if that were not enough, these Chinese made the compass.
As seen before, the first manifestations associated with chemistry began with the Egyptians, the Chinese, and the Babylonians, with activities such as food preparation and handling metals such as iron, gold, and silver. However, there was no theoretical support until Thales of Miletus began in Greece with the study of the composition of matter. Later, Aristotle continued with the theory of the four elements: earth, water, air, and fire. Later, Leucippus and Democritus claimed that matter was composed by tiny particles called atoms. In the 18th century, Antoine Lavoisier laid the foundations of modern chemistry with the law of conservation of matter, which states that matter is not created or destroyed, it is only transformed. By the 19th century, John Dalton scientifically conceived the first structure of the atom, which Ernest Rutherford later complemented with the first scientifically based atomic model, who argued that the atom is composed of small particles. Niels Bohr proposed the structure of the atom in which the electrons were located in energy levels, and Dmitry Mendeleev organized the periodic table of elements based on their atomic weights. In the 20th century, Albert Einstein expounded the theory of relativity. At the beginning of the century, Pierre and Marie Curie studied the phenomenon of radioactivity and discovered new chemical elements such as polonium and radium. At the end of the 20th century, with the studies of the DNA molecule, the language of life would be understood.
The relationship of chemistry with other science. Chemistry is considered an active science with an important value and significance in nature and the development of society. Its subject of study is matter and the change that occur in it. Likewise, it is considered a central science. Chemistry is considered the central science through its laws and theories. It is related to other sciences such as physics, biology, and astronomy, among others. In mathematics, chemistry helps formulate equations and calculations that explain the behavior of matter. In physics, it provides chemistry with laws and concepts. In biology, determines the substances that make up living things and how chemical compounds are involved in biological process. In agriculture, participates in the production of useful substances for the manufacture of different things. In engineering, participates in the research and production of materials that help the construction of some elements. In medicine, assists in developing chemical compounds for the treatment of diseases.
Well, hi, my name is Diego Moya, and I'm going to talk about the classification of matter. Well, everything around us is made of matter. Matter is everything that occupies a space, its mass, and it is classified according to the components of its properties. Well, matter is composed of substances as classified as pure substances and mixtures. Pure substances are a form of matter from which things are constituted. It has a fixed and constant composition, meaning its composition is defined. Pure substances are classified into elements and compounds. The elements are the simplest form of matter, impossible to decompose by physical and chemical processes because the atom is the smallest particle that retains the element's properties. The compounds, these substances are formed by combining two or more elements into a certain property of chemical processes that can be decomposed into simpler substances. Mixtures. It is a matter where two or more pure substances come together, which are combined physically but not chemically, retaining their specific identity and property. In a mixture, the substance with the highest proportion is called a dispersant phase, and the one with the lowest proportion is called a dispersed phase. Mixtures are classified as homogeneous and heterogeneous. Homogeneous mixtures. These are composed by two or more substances. Their composition is uniform. The phases that constitute them cannot be distinguished, and they are also called solutions. The heterogeneous, by the other way, they lack of uniform composition. Their properties vary and consist of two or more distinct physical phases. Classification of mixtures. Mixtures are divided into solutions, suspensions, and colloids. Solutions, well, the homogeneous mixture in which its particles are so small that they cannot be perceived with a microscope and do not settle to the bottom of the container that contains them. Suspensions, type of heterogeneous mixtures in which the dispersed phase is solid and insoluble and the dispersing phase is liquid, with an opaque appearance when left to stand the dispersed phase sediments. Finally, we have the colloids. Heterogeneous mixtures is where the dispersed phase particles have an intermediate size between the solutions and suspensions. Among its characteristics, it stands out that they do not settle.
The general properties of matter are 1. Mass, which is the amount of matter contained in the body. Secondly, we have volume, which is the measurement of the space occupied by a body. Then we have weight, which is the force exerted by gravity on a body. Then we have inertia, which is the property that prevents that its presence are based on the resistance that the bodies present to change their state of rest or movement concerning a reference point. Therefore, the greater the mass, the greater the inertia, and vice versa. Then we have impenetrability, which is a property of matter that prevents two bodies from occupying the same space at the same time. We have porosity, which is a characteristic of matter as it has empty spaces known as pores. Specific properties are characteristics that each substance possesses individually. They are divided into physical and chemical properties. Physical properties are the properties that can be observed and are specific to the substance and can be measured and do not produce a change in the internal composition of the substance. For example, we have state, smell, and color. The chemical properties are referred to the ability of matter to create new substances by determining their behavior when they come into contact with others. Some examples are combustion, oxidation, reduction, etc. Matter is subject to transformation or change. A physical change is a change of matter that do not involve an alteration in the internal structure of the substance. Only its shape or color is affected. A chemical change is defined as a transformation in matter that involves a change in the internal composition of matter, forming a new substance. When a chemical transformation occurs, it is said that a chemical reaction occurs because two or more substances interact and form new substances.